Hey everyone, this is Darshan Senthil and welcome back to this set of videos on trigonometry. So in this video we're going to be looking at another specific concept, again dealing with right triangles. And in specific though, we're going to be looking at some special right triangles. Okay, and these special right triangles are integral to trigonometry. Well, tongue twister right there. So these are integral to trigonometry. So and they will be like, you're going to be using them for the rest of your career in pre-calculus or maybe in calculus. So be ready to know these well. Okay, so let's get started, and let me just get rid of that, and here's our stuff. Okay, so these are the two triangles that you'll be required to know: the 30 60 90 triangle and the 45 45 90 triangle. Okay, now these triangles at first glance are very simple, but there is a little bit more to these triangles that you need to know. Okay, and you're going to need to know their side ratios. Okay, for these triangles there's a fixed side, as I probably told you, for every triangle with a set of angles, their side ratios are fixed. As long as the angles are the same, their side lengths will not change. I think I mentioned that in a previous video. So we're going to use that same principle and we're going to look at some of the ratios of these triangles. Okay, so let's start with this one. It's because it's a simpler one. So if you know that, so what do you know about these two angles down here, 45 and 45? Well, they're the same, right? And if two angles of a triangle are the same, then what does that tell you about their opposite sides? It tells you that they're congruent, right? So it means that these two sides are congruent. And now for simplicity's sake, let's call this side 1. Let's give this side a length of 1. And if that's the case, then this side will also have a length of 1, right? And then if we use Pythagorean theorem, 1 squared plus 1 squared is equal to, let's call that h for simplicity. 1 squared is just 1, so 1 plus 1 is 2. 2 is equal to h squared, so h would be square root at both sides, square root of 2. Okay, so that's and then if we just put that in, this is the ratio of sides. Now again, the ratio may change, like this will be 6 6 and 6 root 2, but the ratio won't change. The side lengths could change, but the ratio will remain the same. Okay, now let's look at this one. This one is a little bit more tricky to view, so I'm gonna draw another triangle to view this one. Okay, so let's say we had an let's say we had an equilateral triangle. Okay, and in an equilateral triangle, all three sides are the same, and therefore all three angles are also congruent. All three side lengths are the same, all three angles are congruent. Okay, and if all three angles of a triangle are congruent, you know that they all must equal 60 degrees, because the angles in a triangle must equal 180 degrees, right? You knew that, right? So knowing this, let's try something interesting. Let's draw an angle bisector. Whoops, let me make that better line. Down into this line. So what this does is it splits up. Let's use a different color. Splits up this into two separate 30. That's a bad color. Let's try a different color. Yep. So it splits this up into two separate 30-degree angles. Right? Because that's what angle bisectors do. And also it splits up, because it's an equilateral triangle, it splits up these two sides into separate side lengths. Now again, let's just assign a length to these sides. So let's call like one of these two bisected sides, let's give it a side length of 1. And we know that this side is half, this huge side down here is the same thing as one of these sides, right? And so if one is half of these, if half of this side has a length of 1, then this entire side length has to have a length of 2, right? And then we could use Pythagorean theorem to solve for the third side. So 2 squared will be equal to 1 squared plus, again, let's just call it h squared, or not h this time, let's call it b squared. So again, 4 equals 1 plus b squared. subtract 1 from both sides. So 3 equals b squared, and b is equal to the square root of 3. So our third side here would have side length of root 3. Hope that was pretty visible. So our final ratio for this triangle is the side opposite the 30-degree angle has a length of 1. The hypotenuse has a length of 2, and this third side down here has a length of root 3. Now this is stuff that you need to know, like you just need to memorize it, like mug it up. And I don't like it, but it's just one of those things that you need to do in trigonometry if you want to be successful. So yeah, that's how it is. And this one is pretty easy to remember. It's just 1, 1 and root 2, like 1, 1, 2, except in a square root. And this one is, I just like to think of it as 1, 2, 3, except that the 3 is in a radical. That's it. Okay. So now, but we're not done just yet. There's one more thing we need to know, as if that wasn't enough, but yeah, that's math, fellas. So let me just get rid of that. So another thing you need to know is you need to know the trig functions. So you need to know the trig functions of these as well. Okay, so you need to know the sine, cosine, and tangent of each of these angles. So you need to know it for this, and you technically need to know it for both of these, but for obvious reasons you'll need to know it for one, because they're both the same, in case you didn't get it. So so sine of 30, 60, and 90. Okay, so you need to know all of these. And again, we could just use SOHCAHTOA to figure it out. So we can just use that to figure it out right now. So I'm just going to do that for you right now. So you should probably, again, you'll be asked to memorize this, so you may want to just try writing it down. Okay, and as I'm writing this down and just deriving it here, just try to look at the different values and see if we can find some patterns. Okay, so that being said, let's get started. So the sine of 30, what is that? Sine is opposite over hypotenuse, right? So that would be 1 over root 3, but 1 over root 3 doesn't quite look the best, so we do this thing called rationalizing, where we just multiply by root 3 over root 3. It's technically 1, but it just makes the fraction look nicer, and it's just math etiquette. I don't like it very much either. So it's root 3 over 3. Wait, no. Oh, my bad, that's tangent. Sorry, my bad, that's not sine, that's tangent. So tangent of 30 is root 3 over 3. Whoops, my bad. So now cosine would be adjacent. Let's work backwards now. So cosine would be adjacent over hypotenuse, which is root 3 over 2. And now finally we get to sine, which is, my bad, 1 over 2, which is just simply 1/2. Okay, I'm getting a bit smudged here. I'm just going to draw these lines across. Okay. Now for 60, let's try this angle here. So again, what's the sine of 60? Let's do this right this time. Opposite over hypotenuse, so that's root 3 over 2. Okay, I hope you can see that. And what's the cosine of 60? It's adjacent over hypotenuse, which is 1/2. And what is the tangent of 60? It's opposite over adjacent, as you can get from this, and that is simply root 3 over 1 or root 3. Okay, well, that should be 45, my bad. Okay, so again, we can just pick any one we like and just work through it. So we can do this one or this one, it's the same thing. So again, sine is opposite over hypotenuse, 1 over root 2. Again, we don't like looking at that, so we clean it up. There we go. And then we go down here again, and cosine of 45, believe it or not, is adjacent over hypotenuse, which is root 2 over 2, same thing. And the tangent is simply opposite over adjacent, which is, either way you look at it, just going to be 1. Now I hope you've looked at a couple of patterns, if you've noticed some patterns in this stuff, in these different values, if you can see them all right. So you might have noticed, if you were attentive, that the sine of 30 equals the cosine of 60, and similarly the cosine of 30 equals the sine of 60. Did you notice that? Hope you did. So we can make this little rule for ourselves here, that the sine of any given angle, I'm just gonna say any given angle theta, is equal to the cosine of its complement, or 90 minus theta. Okay? And in addition, the cosine of any given angle is equal to the sine of its complement. There you go. So those are actually trigonometric identities, but they're good to know right now. They'll help you memorize this stuff. And another thing, which is a little more subtle, I'm not sure if you noticed it or not, but if you notice the tangent actually has a relation to the sine and cosine values. So if you can figure it out, then take a moment to try and do that right now. But if you actually look at it, then you'll notice that the tangent value is simply the sine value divided by the cosine value. So if you just look at it, let's just look at it for each one. It's not that apparent because we're dealing with fractions, but let's just look at it for each one. So for 30 degrees, 1/2 divided by root 3 over 2. Again, it's just flipping the, to divide fractions, just multiply by the reciprocal of the second fraction. So this is 1/2 times 2 over root 3. The 2's cancel. This is 1 over root 3, which, if you recall, is what we got right here. So that works for this one. Now let's try for this one. Same thing, root 3 over 2 times 2 over 1 this time. 2's cancel. Root 3. Voila. Now 45 degrees. Root 2 over 2 divided by root 2 over 2. We don't even need to write it out because it's the same thing. Both sides of both numerator and denominator, they just equal 1. So our third identity, which I think is going to be useful for you, is that the tangent of any given angle is equal to the sine of the angle divided by the cosine of the angle. And those are 3 identities which I think will really help you if you are quizzed on this stuff, or if you just to help you memorize it and be more efficient while writing it. So okay, so that's just some identities to help you know that. And now let's just put these skills to the test. Okay, so over here we've just been given all these, the same table. We're just gonna fill it out again. Okay, but this time we're gonna use our identities. So let's just write them. Let's just take a second to write them out. So then cosine of theta is equal to and the tangent of theta is the sine theta over cosine theta. So those are our identities. We're just going to be working with these throughout. Okay, so the sine